Hey students, this is lesson 10.3. In this lesson, we're going to learn how to find the area of a regular polygon. There's a certain formula we need. And when you do this review, there's an important term you should pay attention to, and that's apothem. You need to know what that is. All right, go ahead and do the review, and I'll check back with you. All right, to find the area, sometimes we need to know some more things about the regular polygon. And the word regular means that all the angles would be the same and all the sides would be the same. So if we look at this regular hexagon, the measures of the numbered angles, we can find the measure of angle 1. That's equal to 360 divided by the number of angles, since they're all congruent, which is 60 degrees. And if we look at the measure of angle 3, 2 times the measure of angle 3 is equal to the measure of angle 1. And the measure of angle 1, we just found out 60. So we can just divide both sides by 2, and we get the measure of angle 3 is equal to 30. And then the measure of angle 2 plus the measure of angle 3 plus 90 has to equal 180. And that's this triangle right here in the triangle angle sum theorem. And we know that the measure of angle 3 is 30. And so the measure of angle 2 is equal to 180 minus 120, which is 60. All right. Go ahead and you try that on the next one. This is a half of a regular octagon here. All right, postulate 10.1 we're going to use here. 2 figures are congruent and their areas are equal. And in a regular hexagon or in any regular polygon, you're going to have some congruent triangles. So go ahead and do 10 and 11, and actually do 10 through 14, and I'll check back with you. All right, so we're going to use this area of a regular polygon as 1/2 the apothem times the perimeter. And so thinking about that, we need to know the perimeter. We're not given that, so let's just write that down. The perimeter is always the number of sides times the length of one side for a regular polygon. And in this case, we have an octagon, which is 8 sides times 12 centimeters for each side is 96 centimeters. And then the area of a regular polygon is 1/2 the apothem times the perimeter. And in this case, the apothem is given as 14.5. And the perimeter, we just figured out, is 96. And so if we multiply those, we get 65.25. So the area of this is 65.25 square centimeters. All right, you try that. All right, here we're going to try and find the area, and to find the area of a regular polygon, this is a regular hexagon. So we have 6 sides here, but the area is equal to 1/2 the apothem times the perimeter. So we need the perimeter, and the only information we're given here is that the side length is 5. But since it's a regular hexagon, we know there's going to be 6 congruent triangles here. And since it's 6, 360 divided by 6 makes this a 60-degree angle. And this is an isosceles triangle. So it's an equilateral triangle. So this distance right here down to the side, that perpendicular distance, my center's off a little bit here, but you get the idea there. Since it's an equilateral triangle, this angle here is 60 degrees. This angle here is 30 degrees, so we have a 30-60-90 triangle. This distance is 5, so the short leg on this triangle is 2.5. And if you remember, the long leg of a 30-60-90 is square root of 3 times shorter leg is equal to the longer leg. So, and that's my half of them. So in this case, A is equal to 2.5 times the square root of 3. We got that. We need the perimeter. The perimeter is equal to the number of sides times the length of one side, which is 6 times 5, which is 30. So now we have everything we need. We're going to take 1/2 times the apothem, which is 2.5 times the square root of 3, times the perimeter, which is 30. And when we multiply that out, we get 64.95. It's an irrational number. We just want to round this to the nearest whole number. So we're going to say it's about 65 square feet in area. All right, you try that. All right, that's it for this lesson. Go ahead and do the lesson check, and we'll talk about it next time we meet in class.